second order linear ordinary differential equations. This lecture we will talking about homogeneous linear ordinary differential equations with constant coefficients. Second order differential equations with constant coefficients. Now this is the standard form of second order differential equations. You can see here y double prime plus ay prime plus by equal to 0. This is, we call it second order differential equation with constant coefficients because a and b are constants, and this is the standard form. How to solve equation number 1? In fact, we have to use the solution y equal to e lambda x. Now if we put or substituting 2 and its derivative, that's mean y equal to e lambda x and its first derivative and second derivative into equation number 1, I will get this equation. Now, due to lambda is a solution of the important characteristic equation, that's mean here this one is a solution, so it is impossible to be equal to 0. So I will take this term lambda square plus a lambda plus b is equal to 0. Then the exponential function 2 is a solution of 1. From elementary algebra, we recall the roots of this quadratic equation. Now I can calculate lambda 1 and lambda 2 from equation number 3. So you can see here lambda 1 is equal to 1 over 2 minus a plus under square root a square minus 4b. This is lambda 1. Lambda 2 the same, just instead of plus I will put minus. Lambda 1 and lambda 2, we can put them in the bases. That's mean now y1 is equal to e lambda 1 x and y2 equal to lambda 2 x. So we have two solutions here, y1 and y2. Now we have the value of the under square root a square minus 4b. Actually we have 3 different cases, depends on this value, that we call it discriminant. Discriminant a square minus 4b if this value more than 0, so I call it case 1. If this value a square minus 4b equal to 0, so I have case 2. If a square minus 4b less than a square minus 4b. Actually we have 3 different cases, depends on this value, that we call it discriminant. Discriminant a square minus 4b if this value more than 0, so I call it case 1. If this value a square minus 4b equal to 0, so I have case 2. If a square minus 4b less than 0, I have case. Okay, for case number one, when a square minus 4b more than 0, now I have two real roots, two distinct real roots, lambda 1 and lambda 2. In this case, a basis of solution of 1 is y1 equal to e lambda 1x and y2 equal to e lambda 2x. Now, because y1 and y2 are defined and real for all x and their quotient is not constant, the corresponding general solution is y equal to c1 e power e1 lambda 1x plus c2 e power lambda 2x. So you can see here I have two solutions with two different lambdas, lambda 1 and lambda 2. But in your minds, lambda 1 and lambda 2 are different. Example. Example 1, talking about general solution of case number 1. Solve y double prime minus y equal to 0. The characteristic equation is lambda square minus 1 equal to 0. Now, lambda square is equal to 1. That means lambda 1 is equal to 1 and lambda 2 is equal to minus 1. You can see I have here two different lambdas, lambda 1 and lambda 2. So this is case number 1. The basis is, or the basis of solution is ex. Now you can see e power 1x and e power minus 1x because lambda 1 equal to 1 and lambda 2 equal to minus 1. So the general solution equal to c1 e power x plus c2 e power minus x. Why we said general solution? Because we have no values of we have no values of c1 and c2. Example 2. This example we're talking about the initial value problem. Initial value problem, that means we have a problem and the initial condition. What is the goal of the initial condition is to find the constants. Solution step 1. General solution. Now we have the characteristic equation is lambda square plus lambda minus 2 equal to 0. We have found this one from the original equation. Now its roots are lambda 1 equal to 1 over 2 minus a, and this is equal to minus 1 because a is equal to 1, plus under square root 9. This 9 is came from a square minus 4b. A is equal to 1 and b equal to minus 2. So the a square minus 4b is equal to under square root 9. So you can see here lambda 1 is equal to 1 and lambda 2 is equal to minus 2. So the basis is e power x and e power minus 2x. Again, the general solution will be c1e power x plus c2 power e minus 2x. Step 2. Now, step 1 is talking about general solution. General solution, we have the constants, unknown constants, C1 and C2. The step 2, we call it particular solution. That means we need to find the solution with the values of C1 and C2. Here we will take the first order of y prime. Now you can see here in the initial condition I have y at x equal to 0 equal to 4 and y prime at 0, that means at x equal to 0 is equal to minus 5. Now the question is why we have two initial conditions, because I have two unknown constants. Let's go back to the applying of the initial conditions. I will make the y prime the derivative of the solution. You can see this is the derivative, first derivative of the solution. Now apply the initial condition in the y prime and y. You can see this is the first initial condition and the second, and this is the second initial condition. From previous two equations I have got C1 equal to 1 and C2 equal to 3. So the answer is y equal to e over x plus 3e minus 2x. Case 2. When a squared minus 4b is 0, in that case I have just one lambda. That means lambda equal to lambda 1 equal to lambda 2. And these are equal to minus a over 2. Do not forget, a is the coefficient of y prime. So lambda here is equal to lambda 1 and equal to lambda 2. In other words, I have just one lambda. I have just one lambda. This lambda is equal to minus a over 2. Hence, only one solution. There is just one solution. y1 equal to e power lambda x. And lambda, as I have said before, is equal to minus a over 2. Okay, what about y2? It must be there is another solution. For the second order differential equation, I have two bases, two solutions, y1 and y2. Here I have just y1. What about y2? In fact, y2 is equal to x y1. y2 equal to x y1. And I will not talking about this issue because it is not important for you, at least for this stage. Now the corresponding general solution is y equal to c1 plus c2x all multiplied by e power minus ax over 2. Again, the general solution is y equal bracket c1 plus c2x multiplied by e power minus ax over 2. Now you can see this is u1 now this one, now you can see this one is u1 and that one, and this one is y2. This is y1 and this is y2. Example. General solution in the case of double root. Now I have y double prime now y double prime plus 6y prime minus or plus 9y equal to 0. Now you can see this is a equal to 6 and b equal to 9. The characteristic equation is lambda square plus 6 lambda plus 9, and this one is equal to lambda plus 3 square. Now the basis is now e minus 3x and x e power minus 3xy, because you can see I have lambda plus 3 square. That's mean lambda here I have now lambda plus 3 multiplied by lambda plus 3 equal to 0. Here that's mean I have lambda 1 equal to minus 3 and lambda 2 equal to minus 3. In that case lambda 1 equal to lambda 2. Lambda 1 is equal to lambda 2. So I will due to e1 is equal to y1 is equal to y2, y1 is equal to y2. Now you can see again here now y1 equal to e minus 3x, and this one is equal to y2, and due to that I must multiply by x. Now you can see due to I have the same lambda 1 is equal to lambda 2, so I multiply y1 with x to get y2. Now the general solution will be y equal to c1 plus c2x multiplied by e power minus 3x. Now example 4, initial value problem of the case double root. Again you have seen here y double prime plus y prime plus 0.25 y equal to 0, and this is the initial conditions. Again, why we have two initial conditions? Because we need two initial conditions to find two constants C1 and C2. Solution. Now the characteristic equation is equal to this value. Again, you have seen I have just one lambda is equal to 0.5. I have just one lambda equal to minus 0.5. Again, lambda 1 is equal to lambda 2. Due to lambda 1 is equal to lambda 2, so this is case number 2. And due to case number 2, I will use the solution. Now you can see this one is y1 and that one is y2. So this is the general solution. Now we need to find C1 and C2. How can we need them? By applying the initial conditions. Now I have to make the first derivative of the solution. So you can see this is the first derivative of y prime. Now put each x 0 here, each x is equal to 0, and y prime is equal to minus 0.3. And for the solution itself, for each x is equal to 0, y is equal to 3. So I have two equations with two unknown. In that case, we can see C1 is equal to 3 and C2 is equal to minus 2. The general solution here, in fact this is not general solution, this is particular solution. This is particular solution. This one is particular solution is equal to 3 minus 2x multiplied by e minus 0.5x. This is C1 and this is C2. This is C1 and this one C2. Case 3. If the value a squared minus 4b is less than 0, I will get lambda 1 is equal to minus a over 2 plus I omega and minus a over 2 minus I omega. By the way, omega is, or omega squared is equal to b minus 1 over a squared. So omega is under square root b minus a squared over 4. In that case, if I have a squared minus 4b is negative, the solution y1 and y2 are, look well here, e power minus ax over 2 cosine omega x and y2 equal to e minus ax over 2 sine omega x. The general solution for case number 3 is y equal to e power minus a x over 2 multiplied by a cosine omega x plus b sine omega x. Maybe you are asked, cosine and sine, where are they from? In fact, this is not important now because we have a long speech about that. So you can concentrate it for equation number 9, which is describe the solution of complex root, or case number 3. Example: solve the initial value. Now y double prime plus 0.4 y prime plus 9.04 y equal to 0, and this is the initial conditions. By the way, here we are talking about case 3. Now the characteristic equation is lambda squared plus 0.4 lambda plus 9.04 equal to 0. So the roots is, now this is the lambda 1 and lambda 2. Lambda 1 is equal to 0.2 plus 3i and lambda 2 is equal to minus 3i. Omega here is equal to 3. Again, omega square is equal to, again, if we go back, now you can see here omega square is equal to b minus a square over 4. So omega is under square root b minus a square over 4. Now omega is equal to 3. Now you can see, and this is the general solution. This is the general solution. Now what about the particular solution? That's mean to get a and b, the constant a and b. First, I will apply the initial condition y at 0 is equal to 0. You can see here a is equal to 0. Now take the first derivative for the solution, this one, when a is equal to 0, do not forget that. I will get y prime is equal to this term. So this is the first derivative of y. Now put each x to 0 and y prime is equal to 3. I will get b is equal to 1. Now, so the solution is y equal e power minus 2x sine 3x. Thank you.